Hi, my name is Steve Rahi. I am a premier field engineer specializing in management technologies. Today's discussion will focus on ConfigMgr Current Branch, specifically the concept of Content Lookup Caching, how that's implemented in Current Branch, the advantages of it, and so on. Right. So the agenda for the discussion basically want to reflect back on ConfigMgr 2012, understand how Content Lookup actually worked in ConfigMgr 2012, talk about then the problem of content lookup, right? Some typical solutions, how the problem of content lookup was solved in ConfigMgr 2012, then look at ConfigMgr Current Branch, how content lookup works there and has changed a bit. All right, so let's just get into it. So in terms of content lookup, in ConfigMgr 2012, lots of factors that can go into it. Boundaries, boundary groups introduced in ConfigMgr 2012. Actually, boundaries and content lookup, the whole process for that has not really changed markedly since 2007. Certainly, boundary groups being added has changed the game to a degree, but the concept of boundaries and content lookup existed in 2007 and so on, right? So boundary groups are huge components in the content lookup arena. So as clients are assigned to boundaries, and those boundaries are in boundary groups, that will have the effect of either returning one set of distribution points that are in your preferred distribution point list, or if you don't happen to be in a boundary where there's local preferred resources, that will put us into a fallback scenario, which will return another set of distribution points and so on. Right? There's certainly content and content types that are supplied when we're talking about looking up content. The location of the client, if it's changed geography, and so on. That's part of content lookup, right? And all of that is driven by one of two stored procedures that exist on the management point of the primary site where you currently reside, either mp underscore get content dp info unprotected or mp underscore get content dp info protected. One of those two, right? So remember, the client will ask for content. It has to ask somebody for content. That will be the management point. The management point will have to access SQL in order to learn about the content that is being requested. That's done through these stored procedures. Okay. All right. So again, two stored procedures. I pulled off the header from the unprotected version of the stored procedure just to show you a snapshot of the kind of information that is sent into the management point, and the management point sends on as a part of executing the stored procedure. Things like the content ID. So this would be the package ID or the GUID that references the software update or maybe an application or so on. The particular version of the content being requested, the site code where that request is coming from, the type, whether it's an SMS package or something else, update or whatever, some flag entry here, the forest, the domain, the client location info, and so on, right? All of that gets fed into the stored procedure. The stored procedure works on it as it processes against SQL and then returns back the information to the management point. The management point then sends that information back to the client. Okay, so have done a lot of examples talking specifically around applications or packages or whatever that discusses this procedure in more detail, but just as a reminder, how content lookup works in ConfigMgr 2012. So I have a 2012 site here that I will pull in, and I have an application here that's ready to go. It's in a failed state. That's okay. We'll just go ahead and hit retry. This is actually an all-in-one site. So this is a client. It also is a management point and so on. So to illustrate, I can go directly to my logs, and here I'll go into SMS underscore CCM. The logs I care about, since this is the client, will be location services first, and since it's the management point, mp underscore location. Okay. All right. So what's I'm going to go ahead and minimize the log folder and minimize these as well. But what will happen is, as soon as I tell it to go look for content, the client will send up to the MP component this request for content. The MP will execute that stored procedure against the database, get a response, and send it back to the client. So I'm going to retry this, and so on. So I have this process going right now. So I'm going to start with location services on the client. That's the component that begins first. Okay, and so we'll just follow it. Okay? So the key, so there's really not so much sending in to the MP. We see the response. Okay, so this is the detail coming back that actually lists the result, but the information is sent into the management point earlier, right? You can see us queuing a location request. Let me see if I can find that in here. Let's see if I can do that. See if I can find that word. Nope, maybe not. Let's see. All right, so timestamp is always our friend. Let's go up to the top of the timestamp here, where things happen. A little bit of noise. So 9:49:43. There, it just shifted. So we'll just start scanning down for a minute, just to show you. So let's see. I must have passed by it. So cached. I'm looking for. Yeah, there it is. Okay, so not obvious, but this is where we're actually sending in the location services request. There's an ID that we send along with it, and we cache it, and then we finally get back a response down here that we will dig into, right? So in between that caching and the response, we go up to the management point. This is the request that was sent in. So again, time frame can help us, but we are kind of in the same time frame, 9:49:43. Okay, so we see the location request come in, and you see the content location request. You see all the detail that we supply in that the stored procedure needs in terms of the package ID, the information. This is an application, so this information is in GUID form. You have the assigned site, the type, which in this case is flagged as an update, the capabilities that we're allowing, right? The AD site name, the subnet information, and so on, is all submitted into the stored procedure. You see, or into the management point, which will translate to the stored procedure. You see all of it is split out here, right? And then you see that we're starting to call some procedures. So we're getting our local site and so on. Now we're querying for our unprotected distribution point. So you see us taking all that information and feeding it into this stored procedure that I referenced a minute ago. This is running against SQL, and then basically we're going to send down this reply. It actually happens twice here, but we send down the reply. This reply includes the distribution points that we can use. This is the reply that comes back to the client in the in this blob of XML. And once the client gets this response, it can go start to download the content, because now it knows where that content's available, right? That procedure been around in 2012 for a long time, been around in 2007 similarly for a while. Again, boundary groups are new in 2012, but the concept is the same. Okay, so that's how it works in 2012. Now, there's a difference in this blob, right? So if you want to, I'll pull this. Well, I've already deleted it. But if you're watching the video version of this and you skip back, you can see the XML blob that comes down to the client. There is a difference between 2012 and Current Branch that I'll show you. If you want to try to see that yourself, before I tell you in a minute, you can go backwards and look at it, and then kind of look at what I'll show you in a second, right? But nevertheless, there is a difference. Okay. Before we get to that, though, let's talk about the problem. So all that seems to work. It's worked for years. It works very effectively. So what's the big deal, right? Well, the problem is that in this process of content lookup, you can see most notably significant load on the SQL server that is servicing the management point. So that is the key thing, the key indicator that you're having a problem is you see SQL overload, CPU overload on the SQL server that is servicing the management point. In many, many environments, that SQL server is the one that also services the site. So it's a shared SQL server between management points and site server. Okay. And while that CPU load is so high, you can't even connect with the console often to do any work, right? So it's a big problem. There are reasons, there are things that can contribute. I wouldn't say any one thing is a particular reason for it, but there are things that can contribute to the problem. Okay, so for example, MSI source control. So this is something that is not used widely in my experience, but it's very useful for MSI packages. We need to be able, when there's a problem, to have a source location where we can rerun the install to do a repair or so on, right? And ConfigMgr offers a really nice way to redirect that source control to leverage content staged on a distribution point for repairs or additions of features or whatever. So if you configure in an application or a package MSI source control, then that MSI file will expect that its source can be located on a distribution point. So every 24 hours, just as a failsafe, ConfigMgr client will check and make sure that content can be located. That's not a big deal. Typically, once every 24 hours for a content location request isn't a problem, right? Even if you have multiple applications or packages using MSI source control. The problem comes in if, in fact, we do a location request for our MSI source, but we can't find it. There's a problem with that, and it's not on a distribution point. Maybe someone took it off of a distribution point by mistake or whatever, right? Then we shift from the every 24 hours to once an hour for that content, right? Well, now if you multiply that across multiple MSI source control scenarios where that's been removed from distribution points, it gets bigger and bigger and bigger. And so instead of once every 24 hours, now these clients are sending in location requests every hour times however many MSI packages have been in a problem state. That can cause a significant increase in load on SQL, right? Another one is available time. So in all of our deployments, software updates, or packages, or applications, or whatever, there is a setting in the deployment to enable only making the deployment available after the available time. Okay, that's great in concept, but in practice, the result is often different than what one might expect. Okay, so to give an example, if you make a particular deployment and you create it at 2 p.m. today, but then you set the available time for 6 p.m. today, okay, and we have our standard policy polling cycle of once an hour. So what, and maybe this deployment in this scenario would be required, okay. So what happens is, as we send out the deployment so let's do the available time. I'm sorry, let's do the not available time and the available time. So if we have this scenario, create the deployment at 2, make it required at 6, and we do not set the available time, okay? We make it immediately available to the environment. Then, since we have the standard default once an hour polling cycle for policy, after 2 o'clock at some point, that content, that deployment, will be noticed by the client. Somewhere between 2 and 3 o'clock, all of the clients in your environment will learn about that deployment. They know that it's going to go required at 6. And so immediately, when they learn about that deployment, they start to download the content. So they're ready when it comes runtime at 6 o'clock. Okay, that's normal. That's good. It randomizes across the policy polling cycle when we start to download the content. Well, if you then take the scenario where we have available time set, then what happens is you create the deployment at 2. All of the clients learn about it randomly across their policy polling cycle, but because it's not available until 6, they don't do anything until 6. Don't download content, don't do anything. And so at 6 o'clock, every single client that you have in that deployment will hit the management point at exactly the same time and cause a load while we process through that particular request for content. All right? And then there's the tempdb. So the tempdb is probably, in my experience, the most impactful thing that you can adjust for helping with content lookup issues, but it's one of the things that very few people actually do adjust. Right, so for the tempdb, the idea is When you install SQL by default, there's only one tempDB. There should only be one tempDB, but inside that tempDB, there should be multiple files typically, right? So, and there's only one by default. So the idea is for every processor core up to 8 that you have, there should be an individual tempDB file. Not log file, but actually database file. And every single one of those need to be sized identically, right? You want to size them so that you don't have to have growth too. Okay, and the reason for that is loading. So if you have a multi-core server running SQL, with 8 cores, 24 cores, whatever, then as we have transactions that have to run against the tempDB, if you have just one tempDB, all of those transactions, even though there might be 8 or 10 or 12 cores running those transactions, they're all segmented to one tempDB. By having more tempDBs, it gives more headroom for SQL to run those processes more quickly, right? And so it's a good thing, right? Sizing tempDB again is a bit more detailed, but in general, 8 tempDBs or up to 8 tempDBs. Sorry, if you have you want to go 1 tempDB per core up to 8, and then there are reasons sometimes to go above 8, but those have to be considered separately, right? But if you haven't optimized your tempDB, you definitely would benefit from that with ConfigMgr. The disk subsystem. So having high-performant disks is very important on a SQL server servicing ConfigMgr, and so sometimes the disk subsystem is not up to par. Could be that you have unexpected growth and have added more clients than you thought originally, and originally the disk subsystem was performing okay. I've seen some ConfigMgr environments where there's a single IDE disk, and that serves the needs pretty well up until a point. For small environments, that's probably okay. Then RAID 5 and then progressing to RAID 10 and so on. The specs for the disk subsystem are pretty clear in our documentation. Sometimes we'll see SANs. Using SANs for storage is not uncommon, but the performance of those SANs needs to meet certain standards. If it doesn't, then we have issues, right, in terms of SQL performance. Boundaries is as big of a configuration, maybe even bigger than tempDB. And so for boundaries, certainly we don't want to have boundary ranges in excess. Okay, that's a problem. If we have boundary ranges, causes a lot of effort in terms of boundary calculation. Having a large number of boundaries in some cases can also cause issues and so on. But largely it's the boundary ranges. Maybe if you have lots of boundary groups for an individual client or whatever, that can cause issues too. But the boundary calculation is oftentimes a significant load on SQL. So what are the typical solutions, right? If people run into this, what do they do to try to address it and get performance back to where it needs to be? So a few things, right? Processor. So it's not uncommon that if you have high CPU on SQL, that the knee-jerk is to add processors, especially in a virtual environment. Okay, pretty easy to add in additional processors. But ironically, adding processors may sometimes actually degrade performance in some cases, right? There's a whole detail about symmetrical adding processes in a way that's symmetrical and so on that have to be considered in virtual environments, right? Not going to get into that here, but it's possible. RAM, right? Why would you add RAM to get rid of or to address a SQL performance problem on CPU? Well, one thought here is that if we can add more RAM, that SQL can put its data set in memory, there's not as much disk thrashing and so on, and so these transactions can happen quicker. That's a decent idea, right? Giving SQL as much RAM as it can have is not a bad thing, okay? With confines, right? Capping the upper limit in some cases is really a good idea. Again, won't get into that here. But RAM alone is not going to resolve the issue. In fact, I can't recall a situation where I was seeing RAM becoming exhausted or even being utilized all the way whenever I saw this problem. So adding RAM is a good thought. It's pretty inexpensive to do, but the impact is not going to be all that great, right? Increasing your disk performance. Certainly, if you have underperforming disk subsystems, Okay, increasing that disk performance is going to help. Okay, but in certain circumstances, it's not going to alleviate the problem. Most circumstances, it probably won't. What I have seen that is very effective at alleviating the problem is introducing MP replicas. Okay, but let's define what I mean by alleviating the problem. Adding MP replicas to resolve an issue with high SQL CPU doesn't really resolve that issue, right? In a shared scenario where you have high SQL CPU and it's impactful enough that the console won't even open, adding an MP replica will actually allow performance to increase on SQL that's hosting the main database so that your console can open, you can do your work. But it doesn't solve anything. It adds more complexity to the environment by having the SQL replicas, right, the MP replicas, and it basically just shifts the processing load to the SQL that's now local on the MP. Right? MP replicas are not bad things. SQL replicas aren't bad things. They are there for a specific purpose. Right? Adding the complexity if you don't need it is something you should avoid in any circumstance, MP replicas or not. But the key point here, it increases your complexity. It doesn't fix the issue. It just masks it. Right? And for that reason, adding MP replicas, while it's oftentimes pointed to and is a typical solution, it's not the best solution in all cases. Right? Adding additional primary sites. So, people who are in this situation of high SQL CPU might add additional primary sites to allow their SQL load to decrease, and that certainly will help. But we publish the support numbers for a reason, right? A single site should be able to support all of the clients that we document that it should support with the right hardware and so on. So adding additional sites just increases complexity without necessarily needing to have those sites. Okay, staggering deployment. So the idea here would be if you have a need to send deployments to 10,000 clients, that you might target 1,000 at a time so that you can avoid the load on your MP. Well, so that will resolve the problem, but it also adds administrative overhead, increases complexity of management, which you really don't need to have in play, right? And then finally, optimizing your tip to be. I already talked about that. That's a good result regardless, and something that we definitely should do. All right, so what about ConfigMgr Current Branch? So all of these things are on the list, just like you saw for ConfigMgr 2012. They're all equally impactful, all equally important, and all equally at play, right? So that's why I put this here. But there are a couple of changes in ConfigMgr Current Branch that help us in terms of being able to process and do so more effectively. So the same stored procedures, right? You notice at the bottom here, I've added in another entry, or sorry, there has been added in another entry. Specifically, boundary group info is a value that is passed into the stored procedure. So if we reflect back to the 2012, there is no boundary group info parameter in the stored procedure. So the implication here is that something has changed in the programming of this stored procedure to facilitate receiving boundary group information from somewhere, right? Meaning that in 2012, one of the functions of the stored procedure was to on the fly calculate boundary group information. In Current Branch, that boundary group information can be supplied to the stored procedure, and if it fits the criteria, be used instead of having to calculate it on the fly, right? And so that is where you get the big performance gains in terms of content lookup in Current Branch. Is the boundary group calculation that happens as a part of content lookup does not have to happen in the vast majority of cases. And boundary group lookup, as mentioned, can be very expensive. And so the question is, how is the boundary group information stored so that it can be submitted to the stored procedure? We'll look at that in a minute. All right, and so on. So let's actually look at how this works in ConfigMgr Current Branch in a demo here. So I'll pull in the environment real fast. Oops. All right, so here I just have a primary site, And then the client I'm going to use for testing is up here. So on the primary site, I've already got my management point log open so that we can see some things as we roll through. In fact, let me get rid of the lock on it so we can roll on through. A lot of activity since I opened that up. Okay. All right, so I'll just minimize that and come back to it in a second. And then on the client, very similar to what I did before, I'm going to just try to download an application. Okay, so here's my rich copy again. Here's my cache just to show, just to remind myself that it's empty. So I'm going to go to try to kick this off. And also here's my log. So I'm going to open up location services. Same kind of thing we did before. Okay, minimize that. Get rid of that and try this, retry. Okay, so it's failed on purpose because I ripped the cache out from under it. Now it's waiting for download, downloading content. So in location services, we will have what we want already. But like before, the first place we'll look, because it's the first place that has detail, is on the management point. And so if I look in the log, right, so let's pause that. So again, timestamp is our friend. This just happened, 12:06. Scroll down. Okay. If I can get this to cooperate, there we go. 12:06. So scroll up to where the processing loop first happened, right here. Okay, so we see that the content location request is coming in. And if I'll pause here because I said this a minute ago, can you tell just by looking at this XML snip what has changed? What's different here? Right? Give you a second or two to look at it, or you can pause the video if you're watching it on video. And the answer is this section right here. The section that details information about boundary groups that the client is in, right? So boundary group information. So we saw in the stored procedure how it had been re-engineered to accept boundary group information as a parameter, okay? So we'll look at the stored procedure in a minute, but this is where it's coming from. The client is actually sending up the boundary group information that it knows about. So that infers that the client actually stores boundary group information locally, which is true, okay, in Current Branch. So here we're saying we're going to send up boundary group information. Here's the time that it was last retrieved, okay? So there's actually 3 rules that are in place to decide whether the boundary group information is valid or needs to be recalculated. The first one that I'll share is this. So if the token here, if the cookie as you would call it, maybe, is within 24 hours of current time, then we'll use it on the management point, okay? And accept the boundary group information that's been submitted. So here's the time generated on the client when the last boundary group calculation was done. And then here's the detail. So in this case, I'm the client's submitting up all of the boundary groups that it knows that it's in. In my lab, my client's only in one boundary group, so it's boundary group ID 1. In a production situation, it could be the client's part of 15 boundary groups, and you would have 15 group IDs listed here. Okay, but in my case, it's just one. So here, this is supplied as part of the request, and then like normal, we'll go through and split all that information out. Here's the information about the get boundary group, IP address, all that kind of thing, so on. Then finally, we'll see, just like we saw before, get info unprotected. This is the same stored procedure. Exactly every time a content location request comes in, this stored procedure is called. The difference is whether this stored procedure needs to actually go through and calculate boundaries again. Okay, so let me show you what I mean. So if I go into SQL, let's look at that stored procedure. All right, just do a connect here. And programmability, and then stored procedures. So if we scroll down to the management point, stored procedure. All right, so get content DP info unprotected. there we go. So here, let's just modify it. Click modify on this, which will open up the stored procedure. And then look at it right away. So first of all, here's what we saw in the PowerPoint slide, that we've added this parameter. And then right here at the very first of the stored procedure is actually logic to define whether we need to go and calculate boundaries. So if the boundary group info is null, or if it's if it exists, I can't remember, equals 0, if it doesn't exist, then we're going to go through and we're going to run the function to calculate boundary group information. Okay, right there. All right, but otherwise we skip it. Okay, so we save the processing time of discovering the boundary group. All right, and then finally we will return the location to the client after we process that on the management point side. All right, now going back to the client on the location services log, we see that we in fact have received the location detail. Let me scroll up here. There. That's the location reply. And you also see in the location reply the boundary group info, right? If the boundary group info, the token matches between management point processing and the client, then we'll just go ahead and use it. But if it's out of date, greater than 24 hours, then we won't. We'll have to recalculate. Okay, so that's one. So I mentioned there are 3 conditions under which the IP information is recalculated. The time skew of greater than 24 hours is one. There are 2 others. So before I get to those, let me open up WMI and show you where this is stored. So WebM test, if I do a connect, and in the location services namespace, enum classes and recursive and OK, and scroll down and then look up. Here's our boundary group cache class. It's new in Current Branch. If I look at it, instances and so on, show moff, then what you see is the last time at which the boundary group information was calculated and the boundary group IDs, what boundary groups this particular client knows that it's in. Okay, so there are 2. So just recall, 1612 is the last time that this was calculated on today. So I'm going to close this down again and come back into it. So if I go into my command prompt, there are 2 ways at which, or 2 things that will happen beyond the age skew that will cause this to be recalculated. The first is stopping and restarting the client service. Okay. Oh, CCMexec, my problem. And I'll start it back up. All right, and then once, so that's one. If we restart the client service, which would happen during a reboot or manually or whatever, we will always force a recalculation of the boundary group information. If we have an IP address change or an AD site change, whatever, then we will also force recalculation of the boundary group information. Makes sense because the client could in fact have moved between one site and the next. Okay, so let's actually reconnect to the WebM test and see if that information has changed. Okay. Recursive, okay. Work our way through to it, show moff, and in fact you notice that the timestamp has changed. So just restarting the CCMexec service, client service, did cause a recalculation just as it should of boundaries and so on. All right, so really that's it in terms of this. This is a small piece of the client, a pretty significant one. That should increase performance. So just wanted to walk through this, show you how it works, and so we'll wrap this up here, and we will see you next time.